Hi everyone, I'm Jake, and it is spooky season, hence the dramatic lighting, and today I'm going to be showing you how to make an animated body for your player avatar in VR in Unreal Engine 5. I'm building this on top of a custom VR pawn that I've been making as a part of this tutorial series, but you should be able to follow this tutorial and implement it into your own pawn if you'd like to. Today we're just going to be getting the basics of an animated body in VR because this is going to evolve into a very complex system over the course of multiple tutorials. So today we're just going to get a good base with a body that moves with the head, has some leg IK, and good arm solving. So let's get into it. First, I'd like to thank my Patreon members. I would not be able to spend the time developing and recording and editing these tutorials without them. They get access to the project files for every tutorial, they get every video early, and they also get a greater say in what tutorials I make. So if you want to help keep the series alive, please consider supporting me on Patreon. It would help me out a lot. Thank you. So in my project, I've added the mannequins pack provided by Unreal Engine, and that's what this new control rig folder is here. And I'm going to be working off of the SKM Manny Simple skeletal mesh, mainly because we don't need all the extra bones and crap that come with the main mannequin mesh. And the main mesh also has one slight rigging issue in one of the hands that becomes very apparent in VR. So we're not going to use that. We're just going to use the simple one. And first thing I'm going to do is add some sockets to each hand. So I'm going to add a hand left socket. And I'm going to add a preview asset. And this is going to be our Oculus Touch V3 left controller. And then I'm going to do the same thing for the right hand. Add socket. And then I'm going to add a preview asset. And that's going to be our Oculus Touch V3 right controller. And then I'm going to rename these sockets. This one is going to be our left controller, and this one is going to be our right controller. And then I'm also going to add a socket to our head bone, if I can find it. Here we go. Add socket, and I'm going to call this one our POV. And I'm going to move that point of view so that it is just in front of the face and about in line with where the eyes should be. This is going to give us the offset between the camera or our headset, that tracked point, and where the head bone should be put relative to it. So that's going to be where our camera is relatively on the mesh. And then we also want to adjust these controller sockets so that the controller lines up properly in the hand about where you'd like it to be. Here, now you can see I've moved those controller sockets so that the controllers are in the hands of the mesh, about where they would be in your hands. And you can go ahead and copy my relative locations and rotations. These ones are for the left controller, and these ones are for the right controller. Go ahead and pause and copy those if you need to. Now we want to actually go into our custom VR pawn and add our mesh to it. So I'm going to select our character mesh right here, and I'm going to use our simple mannequin skeletal mesh. And I'm also going to set the tick group for this mesh component to post physics, because if you don't do that, the animation blueprint is going to tick and use data from this pawn that is a frame old, meaning you'll have a 1 frame delay in your movement, and we don't want that. And now we want to position this mesh properly. So we already adjust the capsule half height every tick to scale it to the height of that, like HMD. And so we're going to need to adjust the mesh's position as well every tick. So I'm going to set relative location, and I'm going to grab our capsule components unscaled half height, and then I'm going to multiply that by -1 because we want to put it below the middle of the capsule. And then if you just go ahead and split that and plug this into the Z, this will position the mesh at the bottom of the capsule component. But I'm going to go ahead and subtract another 2.15 units from that, because Unreal Engine's character blueprint has a gap hard-coded into it between the bottom of the capsule and the ground that it's colliding with, and that gap is 2.51 or 2.15 units. And so this is basically just going to make sure that our feet stay on the floor and not slightly above the floor. And that'll just make it slightly more comfortable for the player's first-person experience. Now I'm going to compile, save, and press play, and we should have our avatar staying on the ground below our head and moving with the player, and that's exactly what we want. Now for rotation, we want the mesh to stay in line with the camera's forward-facing direction. So I'm going to set the world rotation of our mesh. I'm going to split that struct pin, and I'm going to get the world rotation of our camera and split that struct pin. And we're going to use the yaw here, and I'm going to subtract 90 from it just to make up for a little difference in forward vectors, and then plug that in. And now if I press play, the mesh is going to stay in line with our camera. But there's a problem. If I look straight down, the yaw flips and the mesh now moves to face behind us, which we don't want. So let's fix it. I'm going to use the pitch of the camera, and this pitch should be 0 when we're facing, directly in front of us when we're looking straight. And then it should move to 180 and negative 180 as we look up or straight down. So I'm going to take the absolute of this, that should be 90 or negative 190 looking up or down. But I'm going to go ahead and take the absolute of this and say that as long as this is less than 70, then we should continue to set the mesh's world rotation. So now, whenever we're looking straight forward or within 70 degrees up or down of it, the mesh will rotate with our camera. But as soon as I look 70 degrees down or more, the mesh no longer rotates. So if I look straight down, it's not going to be flipping and going crazy. It'll wait until I look back up to align itself. But now we have a problem where if I'm looking down and I turn and then look up, the mesh snaps straight to it. So let's add some interpolation. So let's go back to our pawn, and I'm going to break this link. I'm going to recombine this struct pin, and we are going to use an R interp to constant node. And I'm going to get delta seconds, get world delta seconds, plug that into delta time. I'm going to use an interpolation speed of 150. And for the current value, we're going to get the current world rotation of our mesh. And the target value is going to be what we had plugged in, which is just this camera's yaw minus 90 for the Z. And now if I compile and press play, the mesh is a little slower to interpolate to our camera view, but that's fine. And now if I look down and then up, it will smoothly interpolate to the new rotation instead of snapping to it. And now we've got a good mesh alignment. Our mesh is positioned and rotated how we'd like it. And now we can work on the solving. So let's go ahead and create an animation blueprint for our mesh. I'm going to create one based on the mannequin skeleton here, and I'm going to call it VR body anim BP. Open that up. And then I'm going to create a variable inside here, and I'm going to call this VR pawn. And this is going to be our custom VR pawn blueprint type. That's going to be our object reference. Then we're going to come into our VR pawn, and I'm going to create a variable of that VR body animation type. So I'm going to call this our VR body anim blueprint, and then it will be the VR body animation blueprint object type. Compile and save, And then I'm going to set these references on begin play. So I'm going to create a new function for this. I'm just going to call this gather animation data. And then I will plug that in so that it fires on begin play after everything else. And what I'm going to do here is I want to set our VR body animation blueprint. To do that, I'm going to get the anim instance of our mesh. I'm going to cast to VR body animation blueprint. And I know a lot of tutorials tell you to avoid casting. Don't listen to that. It's literally fine as long as you don't do it every tick. It's a great tool that's meant to be used. So now we're going to have a hard reference to our VR body animation blueprint. And then I'm going to set the VR pawn variable on our animation blueprint to this pawn. So now the animation blueprint has a reference to our pawn, and our pawn has a reference to our animation blueprint. And it's okay that these are hard references, because the main reason you ever want to use soft references or like blueprint interfaces is when you want to have two different actors that communicate with each other but aren't always going to be in the game at the same time. For example, like a helicopter that the player has to ride on, you need the player's blueprint and the helicopter's blueprint to communicate, but maybe the helicopter's only there for like a couple minutes in the game. If you have a hard reference to the helicopter in your pawn, then that pawn helicopter is always going to be loaded into memory. And that's an instance where you'd want to use a soft reference instead, or a blueprint interface, so that the pawn doesn't force the helicopter to be loaded into memory when it's not in the game, when it's not necessary. But because both of these blueprints are always going to be loaded with one another, it's fine to have hard references between them. The only other thing we want to do in this function is get our socket offset data that we set on the skeletal mesh earlier. So I'm going to create a new variable, and I'm going to call this tracking source to bone offsets, and this is going to be a array of transforms. I will set that. I'm going to drag it off and use a make array node with 3 pins, one for the head and each hand, and then I'm going to get a reference to our mesh, and I'm going to get socket transform, and this is going to be in parent bone space. I'm going to use one for our left controller, one for our right controller, and one for our head, or our POV socket that we set. So that's going to be POV. And then be sure to connect mesh to all of these. And then for the controllers, it's pretty easy. We can just use an invert transform node and then plug that into 1 for the left controller. And then we'll plug that into 2 for the right controller. And for the POV socket, I'm going to do a little bit of a conversion just because the spaces are a little bit different for the head bone. I'm going to split these struct pins, do the same thing for the location. I'm going to plug the X into the Z, the Y into the X, and the Z into the Y, and then just plug in that invert transform node like so. And now we have the offsets between our tracking sources and the bones, which we're going to need to solve from. Now it's time to get to work inside of our animation blueprint. So I'm going to get our VR pawn, and I'm going to convert this to a validated get. And on blueprint update animation, we're going to check if we have that valid reference to our VR pawn. And if we do, then we're going to go on to gather our animation data. So I'm going to get our tracking sources being our camera and the left and right controllers. And we're going to get the world transform of each of those. Get world transform. get world transform, get world transform. And then I'm also going to get those tracking source to bone offsets that we created. And then all we have to do is get the corresponding offsets to each of these tracking sources. I'm going to get copies. 0 was for the head, which corresponds to the camera. 1 was for the left controller, and 2 was for the right controller. I'm just going to organize this a little bit. And then all we need to do here for the left and right controller is compose these transforms onto one another. So we're going to compose the offset onto the world transform of the controller. We'll do the same thing for the head, but we'll need to split this struct pin, and I'll show you why in a second. But first I'm going to create a new variable in here, and this is going to be called our bone transform data. And this is going to be another array of transforms. And this is what's actually going to get sent into the control rig to animate the body. So I'm going to set this on is valid. We're going to make an array. And this array is going to have 4 pins. 1 and 2 are going to be the left and right controllers, but we can't plug that in yet because the control rig is going to be operating in space relative to the skeletal mesh while these transforms are in world space. So I'm going to grab our VR pawn, get our meshes world transform, and we are going to make these transforms relative to the meshes transform. So I'm going to use a make relative transform node. We're going to make A relative to the skeletal mesh. And then I'm going to do that for the other controller as well. And plug those into 1 and 2 for the left and right controllers. And then for the head, we just got to do another small conversion. I'm going to take this rotation, plug it into a combine rotators node. On the B slot, make sure that's plugged into B, and then A is going to be 90 in the Y and negative 90 in the Z. And then we will go ahead and plug this rotation into the rotation for our make relative transform node, and then we'll use that unconverted location and scale. Make sure those are being made relative to our skeletal meshes world transform. And then we'll plug that into 0 for the head. And then this last pin, we actually don't need anymore. I forgot that I retconned that. So we can just remove array element pin. And then we can start working on the control rig. So I'm going to make a new control rig under animation, control rig, if it'll let me, animation, control rig, what the heck? Hello? Control rig, there we go. And we're going to call this VR body underscore CR. Open that up, and we're going to import our simple mannequin hierarchy. Scam manny simple, okie dokie. And then we're going to add controls for the head and each hand. So I'm going to right click on the head bone. I'm going to set new control. I'm going to click on that. And then I'm going to change this under shape properties. I'm going to make this one a thick pyramid. And I'm going to lock that scale. And then I'm going to, under the shape transform, scale this up so that it will be like a little hat on our player that we can use to move the head around in this viewport. Like so. And then I'm going to add controls for each hand as well. So let's find the hand left, new control. I'm going to select it. And then I believe I can just put it at 9 and -5 in the shape transform to kind of put that in the hand. And then I'm going to do the same thing for our right hand. New, control, and I'm going to set this one to -9, 5. So now we have controls for our head and our hands, and I'm going to select each one. I'm going to set offset transform from current, and then unparent it. I'm going to do that for all three. Set offset transform from current, unparent, and for the right hand as well. Compile and save. Now I'm going to go back into our animation blueprint. I'm going to go to the anim graph, and I'm going to add a control rig node here. And the class is going to be our VR body control rig, and we're going to use the pins for our head and hand controls. And then we'll get our bone transform data, get a copy of 0, 1, and 2 for the head, left hand, right hand, and throw that into here. This should be 0 for the head, 1 for the left hand, 2 for the right hand. And then I'm going to plug that into our output pose. Now we can work on the solving. All right, now we can actually start solving. So the first thing I'm going to do is set the transform of our pelvis bone. And this is going to just position the entire skeleton so that it is in the position we want it to be relative to the camera, so that we can start solving from a more natural position. And I'm going to get the initial transforms. Be sure to check initial of both the pelvis and the head bone. And I'm going to get those locations. I'm going to make the initial location of the pelvis relative to the initial location of the head bone. And then I'm going to make that absolute from the current location of the head control. And then so if I plug that in, you should see that when we move this head control around, the entire body moves with it, and that's what we want. But still in game, when we look down, we're looking basically straight down into our chest. And so I'm going to add an offset to this, and we're going to do some math to make it so that when we tilt our head down, it pushes the body back a little bit. So the first thing I want to know to do that is how far should I push the body back? And I basically calculate that from the length of the neck. So I'm going to get the transforms, the initial transforms of neck 2, and we'll get the initial transform of the head bone again. And I'm going to put these into local space. So we know there are 3 neck bones, or there are 3 bones in the neck. There's neck 1, neck 2, and then the head. So that means there's 2 distances between them. So if we get the local space location of neck 2, and then distance between that vector and 0, that's going to give us the distance between neck 1 and neck 2. And if we just take the distance between 0 and this location, it'll give us the distance between the head bone and the neck 2 bone. So then we can just add these together for the entire length of the neck. And that's how much I want to push the body back by at a maximum, because we want the neck to be able to naturally solve from that location to the head. We don't want the camera to be further away from the shoulders than the neck can stretch to. And this is where it's going to get a little bit complicated, but I'm going to take the current transform of our head control. I'm going to say 2 vectors and a matrix. And then I'm going to drag off of Y, and I'm going to create the dot product between that and the B slot. I'm going to break the pin to the A slot, and the A slot should be 1 in the Z. And I'll go ahead and show you what kind of values this is putting out, so you can see where I'm going with this. If I plug that into there, you can see right now it's returning 0, but if I tilt the head down, it's going to go down to -1. So this is basically just giving us that pitch of the head. And so I'm going to go ahead and just clamp this between -1 and 0. And then I'm going to multiply that by the length of our neck. And I'm going to plug that into the Y, I believe, for this offset to the location. So now, if I tilt the head forward, it pushes the pelvis back, and that's what we want, because when we look down, we don't want to look down straight into our chest. But there's a little issue where if we look past the ground, like past straight down, the body starts moving back forward because that value goes from 0 to -1 and then back up to 0 on the other side. So I need to make a fix for that as well. All right, so to fix this, I'm going to create another dot node. And this is going to be 0, 1, 0. So it's just the 1 and the Y. And I'm going to plug the Y into B again. And if I print this string, you can see that it's positive whenever you're facing forward, but as soon as you pass the ground, or like straight up or straight down, it's going to switch to negative. So basically it'll just be negative whenever you're looking behind yourself. So if we check if that's negative, so we say if this is less than 0 and this is less than 0, I'm going to drag off of this multiply node. So let's and use a if statement. If this and this are both less than 0, then I'm going to return -1. If they are not both less than 0, then we'll just use that same value we were using before. And now, if I plug this into the print string and move this around, it should push the body back as we go down from 0 to -1. Then it should stay at -1 when we pass that point. And it's behaving exactly as expected. Obviously, if you go too far, so if you turn your head completely upside down, you're looking behind yourself at a 90-degree angle, then it's going to snap back to that forward position. But this is pretty much the behavior that we want. As you look down, it's going to push the body back, and it'll stay back until you look back up. Now I'm going to do the neck IK, so I can get rid of this print string node, and I'm going to add a basic IK node here. Item A is going to be neck 1, B is going to be neck 2, and our effector item is going to be our head bone, and the effector is just going to be the current transform of our head control. And I believe that we can leave everything else as is. Now, when we turn the head forward and back and up and down, it is going to solve the neck to get the head to that point. Now, if I go ahead and go into our custom VR pawn and assign the VR body animation blueprint to our skeletal mesh, we should be able to look down without our head being entirely in our chest, and it seems to be working. I think there's still a little bit of clipping. I think that can be fixed with the near clip plane, and that'll be mitigated a lot once we actually add some pelvis bending and some like neck and spine flexibility in a future tutorial. Right now we're still just doing the basics, and I think it's about time to do some arm IK. So we're going to do some more basic IK for the arms. Item A is going to be our upper arm left, our lower arm left, and then our hand left. The effector item is going to be our left hand control, its current transform. And then for the primary and secondary axes, for the left hand, that's going to be 1, 0, 0, and then the secondary can just be 0, 0, 0. I'm going to go ahead and enable stretch, And I'm going to say stretch start ratio. Let's put that at 0.975, just so that the arms won't stretch longer until they actually have to for it to reach the effector item. And then I believe it's just a matter of creating a pull vector. So I'm going to go into our rig hierarchy, and I'm going to create a new control. I'm going to rename this to left arm pull vector. And I'm going to make this yellow, just so we can differentiate it from the actual controls. And then for the offset transform, I believe I want this to be 200 and -100. Is that right? I'm going to check my reference over here real quick. Yeah, 200 and -100, and make sure that's in the offset transform so that you can compile and save and it'll stay in that point. And then we're going to get that controls transform and plug its location into the pull vector for the arm. So now the elbow will bend towards that location. So if I move this around now, the elbow bends towards that, and we have some arm solving. And then I'm going to do the same thing for the right arm. I'm just going to copy this over so we can keep the settings. This is going to be upper arm right, lower arm right, hand right, and then the effector is going to be our right hand control. And then we're going to create a new pull vector for it. I'm just going to duplicate this one, rename it to right arm pull vector. And then this one is going to be -200, -100 in that offset transform. And then we can plug that in to our pull vector on this basic IK node. And now our right arm should have solving as well, allegedly, if we plug in the basic IK node to the execution pin. I forgot, I've got to change the axes for the right arm, so this is literally just going to be flipped to -1, 0, 0. And now our right arm should solve appropriately. Perfect. All right, and so now if I press play, I should have 2 solved arms, and I do, but you can see the arm, the wrist is twisting when we twist our hands, and that's why we need to implement a twist bone solution. So I'm going to go ahead and do that right after I delete these floating hands because we no longer need them on our pawn. And then I'm going to go into the animation blueprint, anim graph. We're going to create another control rig node. And this one is going to use the CR mannequin procedural that comes with Unreal Engine's mannequins pack. And that is basically just going to fix those twist bones for us. So now, when I twist my hands, the arms retain their volume. There we go. All right. And that's looking pretty good. We're in pretty good shape. Now we're going to do some simple leg IK and call it a day. All right, for the legs, we are going to use basic IK nodes as well. Bone A is going to be the thigh, so I'm going to use thigh left, and then it's going to be the calf, calf left, and then the foot for the effector. The primary axis and secondary axis can stay the same, except we're going to flip the primary axis to -1. I'm going to enable stretch, and I'm going to set this to 0.975 as well. And then we're going to want to catch some data from the input pose. So I've created this input pose variable. The type is rig pose, And on forward solve, I'm going to set that before we do anything else. And I'm going to get a pose cache. It's going to lag my computer. All right, I had to restart my editor. I don't know what it is about this node. It just freaks out every time I bring it in. But I'm gonna add 2 elements to it. They're both gonna be bones. And we are going to save the foot left and foot right poses. And we're gonna leave initial unchecked. So this is gonna get the input animation that we send into this control rig. So this is gonna get the foot's pose like mid-running animation. And then back over here, we are going to start with a sphere trace by object channel, or by object types. And I'm gonna go with world static. Radius of 5 is fine. And we are going to start at the foot's current location. So I'm gonna get transform of our left foot, but I'm just gonna use the X and Y current location for the start and the end of this sphere trace. And then for the Z location, I'm going to get the Z from this input pose. So I'm going to get pose cache transform, and we're going to use our left foot bone, and we're gonna use that Z location for the start and end of that sphere trace. So basically, we are saving the height of our foot when it comes in through that animation, because we're applying these X, Y, and Z offsets to the pelvis that are gonna move it around. But it's like, we don't want to move the foot below the ground and then do the sphere trace from there, because that's not the intended position for the foot to be in. And I actually lied. We're not plugging the input pose Z height directly. We are going to add 50 to it, and that's going to be the start of the trace. And then we are going to subtract 50 from it, and that's going to be the end of the trace. So we're going to just check 50 units up and down from the foot height to see if we collide with the floor. Now we are going to take this hit location here. We're going to take the Z, and we're going to add it to that foot's original Z height from that input pose. And then we're going to make a transform node here to merge all of this together. The X and the Y are going to be the current X and Y of the foot. And then the Z is going to be this added offset from where the ground is from that sphere trace. And I'm going to go ahead and plug in the foot's current rotation and scale, sure. And then this is good, but it's going to make that foot immediately snap to that ground offset. So I'm going to drag off of this Z pin from the sphere trace, and I'm going to do an accumulated lerp. I'm going to say a blend time of 20, initial value 0, and make sure to check integrate delta time. And then that's what we're going to add to the initial input pose, Z height. And then this is what we can plug into the location for our foot effector, but we have a different rotation that we're going to plug in, and we're going to calculate that from the hit normal. So I'm going to get an aim math node, and for our input transform, I'm going to use the foot bone's initial transform. So I'm going to get that, and then foot left, and I'm just going to plug in the rotation, because we just want that original rotation. What's the rotation of the foot when it is flat on the ground? And then we're going to plug in the hit normal for the target. The axis should be 1, 0, 0. The secondary weight should be 0. We're not going to use those secondary units. and the kind should be direction. And now this is going to give us the rotation that the foot should be at so that it would rest on that angle of the ground. But that's not what we want, because we need this to be additive to whatever running or walking animation we input. So I'm going to go ahead and drag off of this resulting rotation, and I'm going to make it relative to that flat foot rotation, and then I'm going to make that absolute from our foot's current rotation, from up here all the way down to here. So basically this is giving us the offset rotation, and then we're applying it to the current rotation of our foot. And then I'm going to use another accumulated lerp node with a blend of 20, and we'll say the initial value is this initial foot rotation, and I'll integrate delta time and plug that in for the effector rotation. Now you can see our foot is flat on the ground like it should be, but our knee is bent the wrong direction, and that's because we need a pull vector. So I'm going to drag off of this transform, and I'm going to create a make absolute node. This is going to be the parent. I'm going to break it off from local. And in local, I'm just going to put 100 for the x and 100 for the y. And then we're going to plug this location into pull vector. And that's just going to create a point that always stays in front of and above the foot for the knee to bend towards. Now, if we move the head up and down, you can see that the leg is conforming to the ground. And in a minute, I'll show you it with some rougher terrain, and you'll see how the foot conforms to that. But first, let's do this for the right foot as well. So I'm just going to copy all of this and paste it over here. In the basic IK node, I'm going to change this to our right thigh, our right calf, and our right foot. And then the primary axis is going to be 1, 0, 0, and our secondary axis is going to be 0, negative 1, 0. And then this make absolute node, I'm going to change the x and the y to both negative 100. And in the axis for our aim math, I'm going to change this to negative 1, 0, 0. And then I'm going to change all of these references to the foot from foot left to foot right. And I believe that's everything we need to do for the right leg to be doing the same thing as the left leg is. Now I've added these little obstacles in here, and if I drag our control rig in, it should create a sequencer where I can see how this is going to behave on our different terrains. So if I move the entire thing over, you can see the feet interpolating. Let me smooth this out. You can see the feet interpolating to the terrain. Same if I move it like forward onto this sphere mesh. It's going to interpolate, hit the floor, and move with it. And our feet should, or our arms should also move nicely. The body should be pushed back when we look down. And everything looks as expected. So let's try it out in VR now. I'm going to go ahead and delete this whole control rig and delete the sequencer it just created. All right, now if I press play, we should have a pretty smooth first-person experience. And yeah, feet are conforming to the ground, arms are solving nicely, body is not obscuring our vision too much. That's something we'll work on in the future. But for now, I am very happy with this. Let's see how it looks in multiplayer. I'm going to change this to 2 players, both as clients. And I already know there is one small issue that is going to need fixed in a future video. And that is a jittering, which you can see if I move my head up and down. And the reason that's happening is because of the capsule half height compression that we did for multiplayer. So that's going to need some adjustment in the next tutorial. But other than that, everything looks like it's working wonderfully. So yeah, thank you guys so much for watching. Again, you can get the project files from my Patreon. This animated body is going to be a permanent addition to this custom VR pawn that I've been making on this channel. And in the next couple videos, I'm going to keep working on it so it's a strong base for our other work. Probably going to show you how to do like height calibration, arm length calibration, calibration saving, like incremental turning. We're going to get some more shoulder movement and neck movement and back movement, and we're going to push the pelvis back when you like crouch down so the body actually crouches. And then I'll show you how to actually get some lower body leg animation in there. It'll probably be another 2 or 3 tutorials, but thank you guys so much for watching. I hope you have a great evening. I will see you all later. Bye.